All right, welcome to today's virtual conference, Operational Integrity, Safeguarding Your OT Systems with Cyber AI, brought to you by IIoT World and sponsored by Darktrace. I'm Lucian Fogoros, I'm the co-founder of IIoT World, and whatever part of the world you are in, thank you for joining. So we have over close to 600 people registered for today's conference, and appreciate you spending time with us. A large part of the value of these sessions is that it is live. It is that you have the opportunity to ask the subject matter expert questions. So feel free to post your question in the Q&A. As a way to incentivize folks to post questions, we are giving away a one-year membership to the VIP community. That's basically waiving the $1,000 fee to join that. So there's a 12 months, and that is going to happen at the end of the presentation, pulling randomly from the folks that post questions in the Q&A. I also like to introduce my co-host, Jeff Majika, the founder and publisher of Supply Chain Cybersecurity News. Jeff, welcome. Thank you.
Thank you, Lucian. Hello, everybody out there, and thanks everybody for joining us. I'm excited to hear these presentations and have a lively Q&A. Thanks for having me.
All right, so in this presentation and Q&A, the subject matter expert, David, uncovers the evolving challenges of securing industrial controls systems, including digitized OT, exponential connections to industrial IoT, and expanding internet-connected supply chains, and why AI or artificial intelligence could be the answers. So I'd like to kick it off with David Masson. He's the Director of Enterprise Security of Darktrace. David, welcome. The floor is yours.
Hi there. Okay, hi everybody. Thanks so much to Lucian and IIoT World for inviting us along today and giving us the opportunity to talk about something that really just doesn't get talked about often enough, which is protecting OT systems. A lot of focus on IT, but today we're going to stick to OT systems. Now, I'm just going to disappear off camera for about 20 minutes, but I will be back for the grilling you're all going to give me at the end when you ask me really, really difficult questions. Okay, next slide. Here we go. Right, this is what's coming up. I'm going to talk about the evolving ICS threat landscape as we see it in Darktrace. Then I'm going to cover some ICS attack trends. And then I'm going to come on to AI-powered attacks, artificial intelligence driving, powering attacks themselves. Then I will explain how we use AI for cyber defense and our industrial immune system approach. And I'm going to give some case studies at the end. One about a pre-existing infection in IIoT devices, one about an ICS attack on an airport, and then a little cute one about how they managed to get into an ICS system via an air conditioning unit. Can you believe that? So, to be honest with you, you guys probably know your challenges better than I do. So I'm just going to go over some of the threats that we see our customers facing on a daily basis. Firstly, there's been a resurgence in powerful ransomware over the past year. This has done significant damage to organizations ill-equipped to respond quickly. And something we have to really take on board here is that this isn't just about ransoming data. It is now possible to ransom operations. You can ransom operations. With the remote workforce, because we've all had to go and work somewhere else other than at HQ, insider threat has taken on a new dimension. This has become worse with the cloud opening up new risks from insiders. Not forgetting, employee error, it's always a problem, not just malicious insider threat. Now, other attackers are slow and quiet. They virtually blend into your environment over a long period of time. Very subtle, very hard for traditional tools to detect. I think we just saw that in the SolarWinds attack last year. And that's where nation states come into that category, and they are on the rise. Nation states are just as likely to attack businesses as they are other states. We also have IT-OT convergence, or IIoT convergence if you want. This has been an issue that's been rumbling on for a long time, and we really need to start paying attention to the fact that attackers can pivot from IT onto OT. Insecure and decades-old SCADA systems alongside advanced tech, exactly. Many of these systems were designed a long time ago, and they were never designed with security in mind. They were designed with safety in mind, but they weren't designed with security in mind. And now we're facing problems, particularly because of the IT-OT convergence. And at the bottom there, I've got an emerging skills gap. What do I mean by that? It's not just that it's difficult to get qualified people anymore. We're also talking about IT skilled groups suddenly finding themselves in charge of OT. We're talking about OT engineers suddenly finding themselves in charge of IT. And that can be a skills gap for both of these people, both of these groups of people. Last but by no means least, and I'm going to come on to it, is the fact that we're going to see AI being used by adversaries to optimize their attacks, making them more targeted and much faster to deploy. So pretty much overall, lots of aggressive threats out there, and it's becoming harder for security teams and traditional tools to keep up. So let's talk, to identify current trends and attacks targeting OT. Let's take a look at 6 high-profile incidents from Stuxnet to Triton and ECANS that have occurred over the last 10 years. Now, while spear phishing is the most common initial vector to get malware past firewalls, other methods include watering hole attacks where a trusted third-party website is compromised, and malware delivered physically through infected media such as a USB drive. I'll talk a bit more about that later, actually. Stuxnet, widely seen as the origin of ICS attacks, was thought to be deployed manually on a USB stick. Havix, which is pretty much the second publicly known ICS attack, it accessed systems through a variety of methods, including watering hole attacks, in which threat vectors infected vendor websites to gain access to systems. Moving on, we see that Black Energy is able to perform reconnaissance. Once they found their ideal target, the attackers direct botnets to conduct what is known as distributed denial of service attacks, but in a very highly targeted fashion. Triton, like recent attacks against operational technologies such as ECANS, exploited the convergence of information on operational technology. To do so, the attack initially compromised enterprise devices before pivoting onto IT subnets. And Triton, by the way, is pretty much known as the most murderous malware out there because it's actually designed, as it says in the slide there, to compromise safety systems and ICS systems. The Triton framework, however, still requires operators of the malware to manually trigger its functions through scripts. In the future, we anticipate an AI-equipped version of an ICS attack operating without command and control, perhaps only calling back at the end of the reconnaissance phase. And I'll go into greater detail about that in a couple of slides. Now, at this point, I'm going to call on Lucien to deliver our first poll of the session. Lucien, back to you.
Okay, thank you, David. So everybody has a choice there to pick one of the 4 options. What are the biggest concerns with securing your industrial environment? So if you don't mind taking the poll, we'll keep it open for another 25 seconds.
Yep, folks, so it's ransomware, or is it insider threat, IIoT convergence, old right-dated systems, or the skills gap that I mentioned?
All right, so we'll close in 5 minutes, so last chance to take that poll. And here we go.
Oh, that's interesting, yeah. Very interesting. Old right-dated systems. I think you pretty much bang on the button there, everybody. That's just the world we live in. It wasn't done deliberately to cause trouble. It's just when they were designed all that time ago, nobody ever could have anticipated what the world of cyber would have looked like in the modern age. I'm also pleased to see that people are paying attention to the IoT convergence, which makes getting onto those old and outdated systems so much easier. Insider threat, not so much of an issue. Ransomware, that'd be about right. You don't get as anywhere near as many ransomware attacks in OT as you do in IT, but it's still an issue. Okay, folks, that was very interesting indeed. Okay, Lucian, I'm just going to head on again. Right, cyber attack trends. What's next? In this section here, I'm going to basically cover off commodity malware. I'm going to look at commodity malware, from OT targeting malware to indiscriminate attacks. I'm going to look at command and control, the ability to blend in with legitimate traffic, and then touching on machine learning software. By machine learning, folks, AI-driven attacks. So we are seeing early signs of machine learning being utilized, which we'll turn to in great. The most striking progression is the shift from bespoke malware designed to hit specific OT targets, like Stuxnet and Havix, we mentioned just before, to the use of commodity malware aimed at generic IT systems, which append basically a small OT-specific module, such as Industroyer and Triton. Now, this change has drastically reduced the cost and range of expertise required to create effective OT targeting malware. And it's also facilitated the progression of OT threats from being pretty much a niche concern to a central part of the cyber threat landscape. We now see increased cases of OT networks being affected by malware pretty much never intended or specialized for them, such as WannaCry ransomware. Traditional enterprise networks are currently a more obvious target for organized criminals seeking to make quick monetization, as the development costs of the attacks are significantly lower compared to attacks targeting OT. But pretty much this will shift quickly if generic IT attacks can be easily ported into OT environments. Command and control channels were used in all 6 attacks mentioned in slide 4. For updates, for exfiltration of data, adding new modules and capabilities, and sometimes allowing humans manual control. Developments in this area include using established websites such as a destination server and using encrypted but common internet protocols such as HTTPS. This often avoids inspection at the network border. More recent C2 can wait until legitimate traffic is occurring in order to more effectively blend in. And finally, we're seeing the early signs of machine learning being utilized. And folks, when I say machine learning, I'm meaning AI here, which we're going to look at greater detail now. Machine learning tools are now readily available to attackers to augment every step of the attack chain. From AI chatbots that realistically befriend employees during reconnaissance, to neural network scanners that automatically select only the relevant material during data exfiltration. Every stage of the attack kill chain can be augmented with some level of autonomous decision making. And I'm saying autonomous here, folks, not automation, autonomous AI. Darktrace has already discovered attacks in the wild that leverage basic machine learning techniques to understand how an infected device normally communicates, and therefore when and how it should be active in order to appear as similar as possible. These attacks will further reduce their chances of detection by reducing the need for one crucial part of the attack chain most likely to reveal them, and that is command and control. Malware that can learn and adapt to its environment and make decisions autonomously will partially or fully remove the need for C2 and pose a significant challenge for most current detection methods. Greater autonomous ability will allow malware to delay establishing a C2 connection. Having to maintain C2, it's pretty much a point of weakness that can reveal the presence of an attack because it's a human being and human beings are fallible. Trained malware can operate independently until, for example, it is able to communicate with an OT control system. So how do they go about it? How do attackers attack ICS? To look at the implications of this development of offensive AI, let's just step for a second into the shoes of the modern cyber criminal, thinking about their motivations. Only then can we really postulate exactly how they would use AI in order to achieve these aims. This can usefully be broken down, as you see on the screen, into 3 categories: persistence, polymorphism, and monetization. Persistence may be achieved by using secondary infections on a single device or by rapidly spreading to multiple devices. Log manipulation is a recent technique that targets traditional SIM log analysis detection approaches. By blocking or altering logs before they leave the infected device, the relevant events are never seen to be processed and the attack goes unnoticed. The key to mitigation is the visibility that a security team has. If the team can see the entire infection, it can be remediated. If they can only see part of the infection, persistence mechanisms are likely to succeed. Polymorphism includes code that continues to reprogram itself to avoid up-to-date antivirus and IDS signatures. Software components that incorporate a polymorphic malware factor, they're easily purchasable. You can go in the dark web. Actually, don't go in the dark web, but if you did, they're easily purchasable. And that meaning that malware changes every time it spreads. This makes developing a signature that can reliably detect the morphing malware extremely difficult. And finally, criminals are always looking, ultimately, in most cases, to monetize their attacks. The anonymity of cryptocurrencies has made this process vastly easier, and the wide use of both ransomware and crypto mining malware have followed. Now, I spoke earlier when we were talking about Triton. I said, what would Triton look like if it was driven by AI? So this is us talking about Triton 2.0. So let's use this knowledge now to imagine what an AI-augmented Triton 2.0 would look like. We can helpfully split this attack up into three attack stages, and they're on the screen there: reconnaissance, access, and persistence. During reconnaissance, there are potential actions which the malware would perform that might trigger detections. Simple IP-based scanning to identify target hosts, mapping network topology to identify gateways and firewalls, protocol-specific identity requests, or the download of PLC programming for further analysis. Now, any of these steps can trigger detection by either violating unknown detection rules, tripwires if you like, in place on the environment, or by deviating from expected behavior of the compromised device if anomaly detection is in place. An AI-enabled framework could include functionality to analyze network communication from the compromised host and attempt to passively construct a network map based on the observed network traffic. If multiple implants were achieved in the environment, these compromised systems could form a distributed peer-to-peer, basically observation network, in an attempt to piece together a more comprehensive picture of network traffic than would be available from one host alone. Moving on to access, there are plenty of risks in this area too. For example, reprogramming of a PLC from a particular host may violate logical zoning requirements. Attempting to directly access a safety device from a non-authorized workstation may be possible at the network level due to insufficient segmentation, but it may still trigger a rule or an anomaly-based alert. Understanding common communication paths could allow the mapping of conduits and plausible behavior types throughout the network. A distributed framework that leverages multiple compromised hosts could select a host to launch the attack by calculating associated risk scores and acting to minimize them. If no course of action was found that satisfied minimum risk requirements, the malware could re-enter the reconnaissance mode to attempt to find different paths and spread laterally to compromise additional pivot points. And lastly, both Triton and previous OT attacks have regularly polled infected controllers to check on continued persistence. This behavior is pretty much unsubtle and could be avoided by the use of AI modules. Future malware could assess the likelihood that persistence has been lost by attempting to identify possible reprogramming and update events in the environment. Based on this information, intelligent decisions could be made to only check the status of controllers based on environmental changes that make it likely that persistence has been lost, without having to get in touch with it. In summary, I'll just let you read that and then I'll say it. So that was from the World Economic Future Series Insight Report from the end of last year. The first generation of AI-enabled offensive tools is emerging. As these algorithms are used in increasingly critical functions, this could have grave consequences, including physical harm, as autonomous cyber-physical systems emerge. Last thing I want to talk about before I explain how Darktrace deals with this. Oh, not yet, Lucian, not yet. Thank you. The purpose of this presentation is most certainly not to spread fear about the malicious possibilities of AI in the world of OT security. It is to tell a more optimistic tale of the capabilities of AI on the defensive side. That's what I really want to talk about. And it is to explain that whilst tomorrow's attacks will easily bypass existing security tools that rely on roles and signatures, defensive AI, defensive artificial intelligence, due to its superior visibility, will win out in this battle of algorithms. Traditional security approaches rely on knowledge of previously defined threats, and they're blind to novel threats, and capable of defending critical systems in a fast-changing threat landscape. As a result, many devices with an ICSOT aren't cyber resilient, posing a threat to the safety and security of operations. Perimeter security is no longer sufficient. With the digital environment becoming vast and complex, increasingly sophisticated spear phishing campaigns, and malicious insiders operating from within, we have to accept the inevitability that threats will get in. With the cyber skill shortage that we face, basically human teams are overwhelmed. It's too much, it's too complex, and it's too fast for them. The attacks move too fast, faster than human beings can think. And this is why we need to start thinking about using AI for cyber defense, a self-learning approach which learns from scratch the ins and outs of the digital environment, the diverse technologies and protocols in IoT devices and industrial environments, as well as email and multi-cloud environments. Now, at this point, I'm going to go back to Lucian and say, Lucian, fire up that poll. Okay, folks. So basically, we're asking you, what are the main challenges your company would face in responding to AI-powered attacks? Is it an inability to spot new attacks? Humans simply can't react fast enough? or it's quite simply an unmanageable number of alerts.
Okay, thank you, David. And we'll be close in about 10 seconds, so please take your selection now. All right, closing the. Here we go.
I love this. Yep, yeah, I'd agree with that. Inability to spot new attacks. It's a problem for OT just as much as it is for IT. Okay, I'm pleased to see on OT people aren't so worried about too many alerts coming up. Yeah, and definitely humans can't react fast enough, particularly with some of that ransomware that's out there. It literally moves faster than human beings can think. When Maersk got hacked, they had people running down the corridors shouting to everybody unplug their computers, but they couldn't run fast enough. Anyway, there you go. Thank you very much, everyone. Right, moving on. What I now want to talk about is Darktrace's solution. And for us, it's self-learning AI. So Darktrace Industrial, our industrial immune system, it's based on a fundamentally new way of approaching OT security. It's inspired by the biological principles of the human immune system. It is designed to tackle the challenges we just talked about, and we call it the industrial immune system. The human body is a control system itself. We evolved to regulate and control the environment around us. And like an ICS, our body is a critical system. If it fails, we die. The body is also highly complex, full of lots of different interconnected systems, far more complex than any ICS we could ever build. So when thinking about how we should go about defending ICSs, we went and looked at how the immune system protects our own bodies. Now, our bodies are attacked all the time by new viruses and bacteria. Obviously, we're in the middle of a pandemic. And of course, your skin protects us to a certain extent, but we still need that immune system because things will get inside. The immune system understands what self is. It is continually learning what is part of me and what is not part of me, and can identify abnormal behaviors when they occur as not self. The industrial immune system replicates this approach for an ICS. Like the human immune system, it is a self-learning system that is continually evolving and adapting to understand normal activity inside the ICS. It develops this understanding from the ground up using unsupervised machine learning and mathematics. Unsupervised machine learning. And because it learns from scratch in every ICS, it doesn't matter what types of devices or vendor or protocols it sees. What we do is we typically take a hardware appliance and plug it into the core of your network, where we configure a tap span port from a core switch, and we then passively ingest as much raw network traffic as possible. We report mirroring it onto our software for analysis. We can do this for OT and IT environments in exactly the same way. We're basically analyzing over 350 different dimensions, measurements, metrics, whatever you want to call it, for every user, device on the network. And from these metrics, the AI creates behavioral models. And we call these models pattern of life models. It is essentially a complex behavioral model for every device and person on the network. From these highly detailed models of normal, the machine learning is able to detect even the most subtle behavioral shifts, and to do this in real time. And this gives unprecedented visibility into the behaviors deep in the core of the network. Industrial environments are being targeted more than ever. We're seeing attacks waged against critical infrastructures on a daily basis. Darktrace enables companies to protect their OT and IT environments and provides a unified security view, which is enormously helpful. As I said, it's deployed passively or actively and adapts to the environment as it changes. We can read through proprietary protocols such as they're on the screen there, Modbus, S7, BACnet, IEC 61850, and many others. But because our technology is self-learning, we don't actually need to understand the protocols to recognize when a device is behaving anomalously. With attacks to critical infrastructure on the rise, the industrial immune system detects some of the most advanced threats, including nation-state activity across your physical and digital systems. And this is how we deliver it to you. Now on the screen up in the top left there, it says Enterprise Immune System. Everybody today, just swap that for Industrial. Basically, we've got two engines here, both based on unsupervised machine learning. The industrial immune system is the unsupervised machine learning that learns the pattern of life on your network, and that's how we use to find threat. If you look up in the top right-hand side, you'll see Darktrace Antigena. This is our autonomous response. This is going beyond flagging the anomalous behavior of security teams, and it's actually instigating an automated machine speed response. By the way, Darktrace Anti-Cheat is the world's first autonomous response technology, fighting back against threats in real time, independent of human action. And as I speak, nobody else can do this. If the industrial immune system works out what the pattern of life is, look upon Anti-Cheat as enforcing that pattern life when it tries to change. Sitting on top of both these systems is our cyber AI analyst. And ladies and gentlemen, this is actually where we're using supervised machine learning this time. What we've done is we've basically automated the investigative triage and analysis function of cyber analysts. And we now deploy it and deliver it straight with AI itself. The training data set for this type of machine learning was 100 of our analysts over several years, where the AI learned how they investigated cyber threat. And we have that for both enterprise and OT systems now. If you look at the bottom there, where we take a platform approach, industrial's there on the right-hand side, but the important thing for you to understand is this is one unified technology right across your entire digital infrastructure. Why? Because threat can land anywhere in your digital infrastructure before it actually gets to where it wants to cause some real damage. In summary, the industrial immune system, self-learning AI, unsupervised and supervised machine learning, learns on the job, no tuning required, does it itself, does all the heavy lift itself. And by the way, when your environment changes, there's no reconfiguration. It just learns it itself. Tailor teach environment, 100% passive, safety critical, passive. We're not touching your network. It's a unified view across the entire infrastructure, cyber physical, IoT, OT, IT, you name it. And it detects advanced and novel threats across the entire infrastructure. For the architectural gurus in front of you, you can have a look at this. This is where we give that enterprise-wide visibility. On the left, we have how we would cover OT, bring it back through industrial DMZ to a Darktrace master appliance, which at the same time could be receiving exactly the same patterns of life from your IT side. What you might notice, curiously from the OT side in that slide, is we don't have SaaS and cloud on OT, but SaaS and cloud are increasingly becoming part of OT structures. People are managing ICS networks through SaaS, and of course, that just increases the threat landscape. So what I would now like to do is go through a couple of examples in the wild of where we find threat. And this is one where it actually happened recently. We detected a series of pre-existing infections in industrial IIoT. This was at a manufacturing firm in Europe. The organization already had Darktrace in place in one area of their ICS environment. But after seeing how the AI could successfully detect zero-day vulnerabilities and threats, they expanded the deployment, allowing Darktrace to actively monitor and defend interactions amongst over 5,000 of its devices and dramatically improving their visibility. An unknown emerging threat was identified by Darktrace's industrial immune system on multiple machines, pretty much within hours of Darktrace being active on the environment. By casting light on this previously unknown threat, Darktrace enabled the customer to perform full incident response and threat investigation before the attacker was able to cause any serious damage to the company. Though it is unclear how long the devices had been infected, it's likely to have been first introduced manually via an infected USB. The affected endpoints were being used as part of a continuous production process and could not be installed with endpoint protection. The next one, this was an attack at an airport. Full disclosure, everybody, this was actually a very, very advanced pen test, okay? Very, very advanced pen test. We recently detected a simulation state-of-the-art attack at an international airport, identifying ICS reconnaissance, lateral movement, vulnerability scanning, and protocol fuzzing, a technique in which the attacker sends nonsensical commands over an ICS communication channel in order to confuse the target device, causing it basically to fail or reboot. Darktrace's industrial immune system detected every stage of the sophisticated attack, using A-powered anomaly detection to identify ICS vectors without a list of known exploits, company assets, or firmware versions. Don't need to know any of that. The attacker leveraged tools at every stage of the ICS kill chain, including ICS-specific attack techniques. Any unusual attempts to read or reprogram single coils, objects, or other data blocks were detected by Cyber AI, and Darktrace's Cyber AI analyst, the supervised machine learning part of our solution, also automatically identified the activity and created summary reports detailing the key actions taken. The attack spanned multiple days and targeted the building management system and the baggage reclaim network, with attackers utilizing two common ICS protocols. In this case, it was BACnet and S7Com, and leveraging legitimate tools such as ICS reprogramming commands and connections through SMB service pipes to evade traditional signature-based security tools. Folks, I'm going to skip this one because we're getting close to the end. I want to give enough time for some questions. So I'm going to say thank you very much for paying attention. I'm going to come back on screen now, if I can find my camera. And invite Lucienne and Jeff to come back on, and we'll do the Q&A.
All right. Thank you, Dave, for that. If you don't mind, stop sharing the screen so everybody can fit on a screen. Welcome, Jeff, to this section. So we're moving to the Q&A portion of today's, where we will entertain a series of questions that are coming from the audience. So as a reminder, we have two options by submitting questions in the Zoom Q&A tool or via Twitter or on LinkedIn, leveraging the hashtag Darktrace_ICS. And of course, the content from today's session will be made available after the conclusion of the virtual conference. So in the event we don't get to all the questions, we will carry the conversation over the social media and address them via Twitter and LinkedIn once again, leveraging the hashtag Darktrace_ICS. So maybe the first question we'll take is around the support for industrial controls protocols. Now, when I was working with an industrial supplier, we had over 300 drivers and protocols. Does Darktrace need to support or have to be able to read all of these ICS protocols?
No, not at all. We do read many of them, and I rattled off a few of them in the presentation there, and we're actually working on more of them as time goes on, because customers pretty much ask us to be able to do so. But no, we don't need to be able to read them whatsoever. For the individual packets that are being analyzed off the wire, we're not actually interested in what the payload is. Those measurements I spoke about, we take from outside the payload, okay, in order to build those partner of life models. We don't really need the data itself. And if it was an IT network, if it was encrypted, it's the same thing. We're not fussed if it's being encrypted, because it's not what it is that's important here. It's what is it doing on the network, on the OT network, that's going to define whether it's malicious or not.
Yeah, so Tim was asking, how do you deal with AI engine not recognizing the new equipment or process triggering the algorithm?
Yeah, okay. So when we put the AI in there, it will discover everything that's an IP connected device in a network. So something new comes in, it will see it. It will see it straight away. Perhaps the question might be better phrased in terms of, would it consider the appearance of a new device on the network as threat? It will certainly recognize it as a change. And the thing about Darktrace is, I mentioned some of the mathematics in there. It's called Bayesian recursive estimation. And what that does is it gives you a score of how much of a change to the pattern of life something is. So if there's a new device in the network, yep, it's going to say it's new. It might well alert. In fact, in an OT network, it probably would, because it's a new device, because we want to make sure that it's a new device that's been put on there by the host, the people who own the ICS, not somebody else. But it would give you a score, because at the same time, it will be looking at all the other devices that it kind of belongs to. The AI is very good at doing clustering, where it brings like-minded devices. I'm using human terms here. Remember, the AI just thinks of the network, not of the network, and contrasts and compares them. So that new device, it would look at it and go, is it like any of the other devices? Is it doing the same thing as the other devices, or is it different? And if it's really different, that score would be higher. And the higher the score, the more deserving it would be of your security team's attention. Obviously, 90% score, you want to be getting on it right now. 20%, you might wait for a couple hours or till tomorrow.
Question here from the audience I thought was worth bringing up. Question is, how does your tool work in an environment where the network switch is under a heavy load due to attack activities and can support the communication of critical data over the span/mirror port? So is there any degradation of what Darktrace can do when there's actually, when the network is actually under attack?
Darktrace will be analyzing all the traffic all the time. So long as the traffic's coming, as long as we're still able to port mirror that onto the AI, it won't matter. I have to be quite honest with you though, is if we don't see traffic or we don't see particular streams of traffic, then we can't analyze it. We won't be able to see it. What we will definitely be able to alert you on is if we were previously analyzing a stream of traffic and it suddenly vanishes, pretty much will light up like a Christmas tree and tell you.
Okay, that's a good. I think that's a good answer. Another good question. I'm not sure anybody knows the answer to this one. Is by Ani. The application of AI to cybersecurity opens a new vulnerability. I think it's a good point. Adversaries may learn to feed disinformation to AI systems, creating an automated agent, which is an interesting point. Care to address this issue, which I think is interesting?
Okay, what you mean effectively poisoning the network traffic? Do you think that's what the individual meant? Absolutely. Yeah, it could be. The key thing here is, remember, I keep talking about this pattern of life. That would be a change to the pattern of life. We'd have seen we're seeing particular devices and traffic behaving in a normal way, and then suddenly it would change. In this case, because somebody's trying to poison the traffic or change it, and the AI would see it and would, depending on the change, and bearing in mind if somebody's doing that for malicious purposes, it's probably going to be quite a big change. It'd get quite a high score, and we would alert on it. By the way, if somebody was deploying anti-GINA on their ICS networks, and everybody I know, it's kind of a bit of an issue, actually taking action on an ICS, okay? But what it would probably do in that case, it would stop that particular traffic. That would stop those communications, that poisoned traffic. But that would depend if you were deploying anti-GINA.
Okay, awesome.
By the way, that's quite a common question. That's quite a common question. People asking about poisoning traffic, poisoning data sets.
Yeah. I mean, it's a garbage in, garbage out, right? If you're fussing with the data, but if you notice the data is changing, that's in and of itself would be a noticeable thing. A lot of good questions here. Let me get to another one. I don't want to take too much of everybody's time. John Doe's got a good one. Asset visibility is is the first concern that industry has to deal with when considering ICS security. Can AI be leveraged to automatically inventory IoT assets, and if so, how? I think that's a good question. I think you answered it already, but I'll let you give you a chance to swing at this one again.
No, it's still actually quite a good question to ask, because the way you do that between IT and OT are a bit different. On IT, basically we'll discover every IP connected device, internet IP connected device, very, very quickly in a couple of minutes. On the OT side, same applies. We're doing that from all the traffic that we're port mirroring onto the AI for analysis. We're not marketing ourselves as an asset management tool. We're marketing ourselves as a cybersecurity tool. But if you think about on the IT side, for audit purposes, you can't hide from this. If you're on the network and you're there, you're going to be seen. On the OT side, sometimes a lot of products out there that actually have to go and find where the devices are. We currently think we don't need to do that, because we'll take it off from the traffic that is there. But we are actually looking at active polling to find devices. But you've got to be very careful about that when you actually send that out. For instance, if you had an old PLC that was pretty much on its last legs and had been in there for 40 years, and somebody suddenly then polled it to say, who are you and what you're doing, it'll probably break and fall over. So it's a bit of a tricky issue. It can be done, but you've got to be careful how you do it.
Just Paul, another question. So my operation technology network is completely air gapped. What value does AI bring? Is one of the questions came in.
Okay, I'm absolutely sure that the questioner is confident that the OT system is air gapped from the internet. I'm not so confident, to be honest with you. Now, I'm pretty sure there'll be something in there that's talking to the internet somewhere by now in 2021. But in the old days, that was the way it was protected. That's why they didn't have to design it for security, because it wasn't connected to the internet. Now that's increasingly not the case, particularly because of IIoT. But let's just say it is completely disconnected from the internet and it is completely air gapped. It wouldn't matter. For us, you probably still want to know exactly what's going on in that network. You want to understand what normal behavior is on that network, so you can look for change and threat in real time. Because even though it's not connected on the internet, through the internet, you're still going to bring in new devices which came from somewhere else. We're talking supply chain attack here. And you've got to trust the people who are giving you the new PLCs or HMIs that they're okay, that there's not something already in there. And that does happen. You may have third-party vendors, or not vendors, or People who come in and work on the system, who plug in to the system, whether it's their own PCs or their own USB sticks. I mentioned an attack that began on a USB stick. And a little bit of background, that's exactly what it was. It was a maintenance guy stuck a USB stick in, and bingo, world of pain. So you're still going to need to be able to protect those air-gapped OT networks and to really understand what's going on. And I keep reiterating this, so you can see changes to the environment, the initial breadcrumbs of attack in the early stages. And if you get them in the early stages, you stop them, and guess what? You don't get hacked.
Does autonomous response take action on the ICS devices?
Yes, you can deploy autonomous response in ICS systems. As I said a few moments ago, it's a thorny, tricky subject. To be honest with you, traditionally you don't want to touch anything in an ICS system because you're frightened it's going to break and fall over. And they're designed for reliability and resiliency and to keep going. But increasingly they are becoming more resilient. The devices on there are more resilient, and you could use autonomous response. And in many cases, you may want to actually stop that a threat in its tracks, particularly if it's fast-acting ransomware, which starts encrypting devices at a rate faster than human beings can think.
I'll move on to one of the questions from Steve. So he's asking about, is your system able to block cyber attacks on ICS network, or can you identify faulty status level readings coming from a PLC, for instance, DCS to the operator, HMI system?
Okay, now that's a tricky one, Steve. Faulty readings. That's really not what we're about. We're about the device that's providing faulty readings doing something that's outside its pattern of life, and perhaps providing faulty readings isn't necessarily indicators of a cyber attack. It's a really tricky one. I've been asked this before, and as you can see, I'm struggling to actually to explain what this would be. If there's something wrong with how the device operates in its normal environment, that's not really for us to report on. It's if that, no, that's not what I'm trying to say. If the readings themselves are false because it's broken, that's not necessarily malicious. If it's broken, if the readings are false because some malware's got on there that's making them suddenly change their own pattern of life, then yes, we would say that. That's not the best answer, Steve. I'm feeling a bit guilty about that, but that's what I'm trying to say.
I have a question here about the AI. What criteria are used to identify data pools? What is the AI, how does the AI identify the data pool that it's going to use to learn for a SCADA system that can support the cybersecurity?
Okay, it's basically all the raw network traffic, all of it, absolutely all of it, which we want to tap into through a span or a tap somewhere in a core part of your network. As I mentioned before, we do not touch your network. By the way, when I say we, forget about the we. There's no human beings involved. It's not me doing it. It's the AI doing it. It's just we tend to say we, okay? So what we're then going to do with that traffic, in order not to touch it, because we do not want to be in line, don't want to be in line on IT, never mind OT, because you're in line on OT, things go wrong. We port mirror it, all of it, onto the software for analysis, okay? Port mirror it onto the software for analysis. And we take, and there's no limits, we'll take all the traffic you have got. And it doesn't matter how big you are, we do some big industrial deployments, we do some massive IT deployments as well. Because when we're taking those measurements off every single packet, the actual amount of traffic, it's usually about 1% of bandwidth at the end of the day. You might not believe, but it's not that much. Anyway, we can take it on, port mirror onto the software, and start doing the analysis, start building those pattern of life models.
Here's another good question. Starting back at the beginning here, what's the best protection starting place for helping legacy ICS? I think that's so you're coming at this. There's a problem. What are the first couple steps, I guess, to think about when you're talking about legacy?
You mean at the start of an attack? Oh, sorry, legacy.
Yeah, legacy.
The first step is, folks, accept it's going to happen. All right, accept that it's going to happen, and start moving away from the outdated legacy approach of basing your cybersecurity on what has happened in the past. Okay, there are many cybersecurity products out there for IT and OT, and they're all based on rules and signatures. And what that means is they've required victims before they've come up with solutions. And we fundamentally reject that that principle that you can decide you can protect yourself in the future because of your knowledge of what's happened in the past. That's not really going to work anymore. So accept it's going to happen, and accept it's probably going to be something you've never seen before. It's going to act in a way you've never seen before, and it's not going to be in your firewall. It's not going to be in your virus checking material, whatever. So accept it's going to happen. That's what you want to, that's right at the beginning. Accept that. The second thing is then to deploy a technology, and I'm going to suggest it's ours, but deploy a technology, in our case we're using AI, that will show you exactly what you've got. Because if you think about it, if you've got a real understanding of what you've got, you know, it's your land, it's your territory, it's your place. You should know everything about it and understand it like the back of your hand, so that when something appears that's not been there before, you'll see it immediately and be able to say, what's that? What's it doing? What's it about? Rather than the situation we've currently got, where people don't know what they've got, they don't know their landscape, they don't know what's going on, and that's why hacks take place, whether it's OT or IT. And the bad guys, threat actors, know this. They know they can't be seen. Invest in technology that gives you that visibility, and that will be the second greatest step you can take. The third one would be is to accept that in the modern era, it's going to be too much, too complex, and too fast for your human security to deal with. Bring in some AI to do the heavy lift on configuration and the heavy lift on finding that threat for you, and in some cases, stopping it for you immediately. Now, folks, this isn't Skynet. This isn't about AI replacing human beings. This is about AI augmenting that scarce human resource. This is about AI giving human beings a chance in the fight. There you go.
Here's a question. So it's more around the standard, the 61850. So the question is, who will be responsible for the AI in the OT environment? For example, in the case of emergency response in an IEC 61850 communication, in case the AI reacts wrong. This is probably kind of a debate that could take offline for quite a longer time.
Okay, sorry, can I just redefine that question? Is this where the autonomous response is considered to have stopped something it shouldn't have stopped?
That's what it appears to hint towards. And who's the responsible for it?
Okay, because I'm very confident the AI will make a correct judgment about what's actually happened. Either be a change to the pattern life of device or whatever it is, regardless of what protocol it's doing. If you're actually deployed autonomous response, and I mean, don't forget, in many of these situations, you probably don't want any autonomous response. You're probably happy to accept that there is a virus on a piece of kit, but it's still, you need the piece of kit to continue actually working in the environment, because otherwise your production stops. But anyway, putting that aside, the autonomous response is fully configurable. You can stop it and reverse it. So there you go. You can actually do that. Earlier on, when I was giving the examples, I spoke about where some devices had been affected by a USB stick that we put in. I've actually written a blog about that. It's on our website if you want to go and have a look at it for further detail. But the issue with that was our AI detected malware. Right now, I've forgotten the names. It was two different types of malware. I've forgotten what it is. We detected it. And the actual company then checked with the supplier, and the supplier did say, yeah, actually, we have had a problem with that. So it had been around for quite a long time. So shame the supplier never told them when they gave them the devices. But anyway, there you go. But they had to keep them on production. Now, although we detected the malware, and the malware was doing scanning and not scanning, it was messaging out and looking around. It wasn't leaving the affected devices. It was just sitting on them. And so the client said, you know what, we're going to leave them in because they could now use our AI for constant monitoring to make sure that the threat level didn't get any higher, didn't spread to other devices, because they actually needed to keep them in to keep production going. And they will continue to do that until the point at which there's a new type of PLC and HMIs that they can bring in and swap them over, but they're not able to do it at this moment. So there's an example of AI finding a threat and controlling a threat, but without actually stopping it, just giving that constant monitoring.
Thank you, David. And for that, we will include in the follow-up email after this, that particular link to the blog post that you referenced. Jeff, any questions from your end?
Yeah, I have one probably last one here that I think is interesting. It's probably an outlier case, but I think it's an interesting one. So,
Oh no.
uh, so what if Darktrace is deployed on a system that has abnormal? What if it gets deployed on a system that's already compromised? So if you deploy
Love
Darktrace
it.
and it's already been so that the AI is training on an already compromised system, how is that? How are you able to figure out that that's not what it's supposed to be?
Thank you, Jeff. That's a fantastic question. We get asked it literally all the time. I've been asked it so many times over the last 5 years since I was in Darktrace, and it's a very, very valid question. One of the things you'll see us doing when we're doing our presentation is we always tell you that we will find something wrong on a network. Yeah. Would our AI, when it's plugged into an ICS network for the first time, consider that the existing malware is normal for the network? Yes, it would. In the first couple of minutes, yes, it would do that. It would see it and think, oh, yep, that device is meant to be beaconing out to an obscure 100% IP address in North Korea, let's say, okay? It would think, yeah, well, that's what it's supposed to do. What the AI does, and I alluded to it elsewhere in the talk, is it's very good at recognizing similar devices, similar people on the network, similar subnets, etc. And it starts, we call it clustering, bringing them together and starts comparing and contrasting between these different devices. And that's how we discover threat that exists on networks already, because in doing so, now remember in ICS networks, most of the devices are very, very boring, but they do this. They're very boring. There's lots of them, but what they do lots of times forever. And very quickly, the AI would realize that, let's say, of these 50 PLCs, there's just this one that goes beep to that 100% rare IP address in North Korea, and the other ones don't. And that's pretty much how we discover existing threat on networks. Does that make sense?
Yeah. Yeah.
I'll give you another example. Way back, this is quite a long time ago actually, we installed in a huge power station in the UK. Now, admittedly, this was on the IT side, not the OT side, but we now do their OT as well. And I was there, we actually plugged in and we drove off. And within an hour and a half, the AI worked out that of their 5 DNS servers, one of them was going beep to a 100% rare IP address. All I'll say is east of Berlin. And it managed to work that out in an hour and a half. There you go.
All right. Well, that's a very good answer. I'm not sure how much time we have, Lucia, and it's probably a good time for me to hand this back over to you to take it in for our drawing and the closing comments.
Thank you. There's a lot of great questions. So I just got a note from our publisher. Everybody that actually posts the question, the Q&A, will be offered an invitation to the VIP community. So stay tuned. We'll grab your emails and send you the invite. So anybody that's in the Q&A will be getting invited. So there's a lot of great questions. So we want to thank you for taking the time to join today's session. Visit our events page for upcoming educational webcasts brought to you by IoT World, including the IoT World Manufacturing Days on March 18. I think we have several other ones on cybersecurity prior to that. Special thanks to our Darktrace for these educational sessions, and to our guests, Dave and Jeff, for your contribution. Much appreciated. If you have a suggestion on a topic or otherwise, we always welcome feedback. So drop us a message and follow us. If you like what you heard today and would like to subscribe to our newsletter, feel free to do so at IIoT_world. This concludes the program for today.